So hi everyone, my name is Shivam Bohra. Welcome to the official channel of CodeChef. So if you want to learn and master data structures and algorithms, or if you want to do really good at competitive programming, then this is a one-stop destination for you. Now before we actually get started, here's a quick reminder for you to hit that subscribe button if you haven't already yet. So now let's move on to the next problem. So the problem statement says that given an array of size n, print the maximum continuous subarray sum, right? So we simply have to find a part of this array. So let's say my array contains -5, 2, -1, 3, -4. So in this array, we have to find a part of this array, a continuous part of this array, which will offer us the maximum sum, right? So in this case, this sub array 2, -1 and 3, this will offer us the maximum sum, right? And the maximum sum would be 2 plus -1 plus 3. So this would be 2 and 3 would be 5. 5 minus 1 would be 4, right? So in this case, our answer would be 4. So now let's move on to the constraints. So the size of this array, it could be as big as 10 to the power 5. So n could be as big as 10 to the power 5. Hence, an n square approach would not work in this case, right? And also the array elements could be negative as well as positive, right? So now let's move on to the approach. So if all the array elements are positive, so we can simply add all of them. So 1 plus 2 plus 3 plus 4. In this case, it would be 3 and 3, 6 plus 4, 10. So if all the array elements are positive, we can simply add them up to get the maximum subarray sum. If we have only negative elements in our array, then in this case, if I try to add these numbers, so let's say I'm adding -1 and -2. So -1 plus -2 would be -3, right? So if I take this subarray, then my subarray sum would be -3, which is even smaller than these two. So let's do one thing. Let's only take this subarray. So this way, my sum would be -1. If I take only this subarray, my sum would be -2. If I take only this subarray, my sum would be -3. And if I combine them all, then my sum would be even smaller. Hence, in this case, the largest possible subarray sum would be -1, right? So if we have only negative elements, then the largest one would be the maximum subarray sum, right? This -1 would be the answer. So to find the maximum subarray sum, firstly, I'll create a new subarray from the very leftmost element of this array. And then I'll see whether to include the next element or not, right? So we can include -1 with this 3 and we can have 3 minus 1. We can have 3 minus 1. Or we can start off by creating a new subarray with this -1, right? So we can create a new subarray with this -1. So we will have two subarrays over here. Now, whichever out of these two subarrays is able to make a larger sum, we will go on with that subarray. So in the first case, 3 minus 1 is able to make a sum 2 and only -1 is able to make a sum -1. So we'll go on with the larger subarray, which is 3 minus 1, right? So for this -1, I'll have two choices, either to merge it with the current subarray or to start a new subarray from this point, right? And similarly, I'll go on with the next element. And again, for this element, I'll have these two choices. So now we have this array, -5, 2, 3, and so on till 1. So in this array, the subarray having the largest sum would be this 2, 3, -1, and 2. If I add them all, then I'll get 5 minus 1 plus 2, which is 5 minus 1 is 4 plus 2 is 6. So the largest possible subarray sum from this array is 6. So let's see whether we are able to make a subarray sum of 6 from this array using our method or not, right? So firstly, I'll have -5. So -5 is my current subarray sum and maximum subarray sum till this point, right? So initially, -5 is my current subarray sum and also my maximum subarray sum, right? So then I'll move on to 2. So I have two options, either to merge this 2 with this -5, either to have -5 and 2, or to just have only 2, right? Now, which out of these subarrays, is able to make a larger sum? In the first case, I'll get -3. In the second case, I'll get 2. So second option is better. Hence, it is better to start a new subarray for this 2, right? So I have created a new subarray for this 2. So now my new current subarray sum is 2. So now my new current subarray sum is 2. My max subarray sum was -5, so I'll change it to 2. Now I have 3. So either I can start a new subarray or I can merge this 3 with 2. So I can either have 2, 3 or just 3. So this subarray is going to result in a sum of 5, and only 3 is going to give me just 3. So 5 is better. Hence, I'll go with this subarray 2 and 3. So 2 and 3 will give me a subarray sum of 5. So I'll change my subarray sum from 2 to 5. And also my max subarray sum was 2. So I'll change it to 5, right? Now I have -1. So again, I have two options, either to merge this -1. So I'll have 2, 3, -1. So in this case, my subarray sum would be 5 minus 1, which is 4, or I can only have -1. Start a new subarray with this -1. In this case, I'll have a subarray sum of -1. Option 1 is better. Hence, I'll create this subarray, right? 2, 3, -1. So now my subarray sum would be 4. So now my current subarray sum is 4. And my maximum subarray sum would remain as it is. So now we have this 2. So I can either merge this 2. So I can either have 2, 3, -1 and 2, or I can only have 2. This first subarray is going to have a sum of 2 plus 3, which is 5. 5 minus 1 is 4. 4 plus 2 is 6. And the second subarray is going to have a sum of 2, right? Clearly 6 is greater than 2. So we'll go on with the first subarray, right? Hence, I'll merge this 2 with the current subarray. So this is now my current subarray having a sum of 6. So now my current subarray sum is 6. And also my max subarray sum was 5. So I'll change it to 6. And then I'll move on to the next element, which is -4. So again, I have two options. Either I can have 2, 3, -1, 2, 4, 2, -4, or I can only have -4. In the first option, the sum till this 2 is 6, and -4 is 2, and -4 over here is -4, right? So 2 is greater than 4. Hence, we'll merge this -4, right? So now our subarray sum after merging this -4 would be 2. So now my current subarray sum is 2. And at the very end, I have this 1, right? So again, I have two options, either to merge this 1. So if I merge this 1, then my subarray sum would become 2 plus 1, which is 3. And if I only take this 1, I start a new subarray from here, I'll only have 1. So 3 is better than 1. So I'll merge it. So now my final subarray sum is 3. And we can easily see that our maximum subarray sum at any point while iterating this whole array was 6, right? So we can easily get this maximum subarray sum using this method, which is also called as Kadane's algorithm. The time complexity for this approach would be big O of n, since we are linearly traversing through this array, right? So to simplify this, I'll have two variables, C sum for the current sum and M sum for the maximum sum. Initially, my first element is my current sum as well as the maximum sum. So I'll initialize these two variables, C sum and M sum, by the very first element of this array, which is ARR of 0, which is the 0th element of the array. And this is the second element of this array, right? So now what I would do is I'll start iterating from the second element of this array till the very last element of this array, right? So my current sum at any moment would be either this element itself, because I can start a new subarray from this element. So my current sum could be either this element. So in this case, either it could be this element. Let's call this as ARR of I, the ith element of this array. So either it could be ARR of I, my current element, or either it could be my current subarray, right? Or current subarray sum. So either it could be 2 minus 4. Now we know that the current subarray sum, excluding, if we don't include the last variable, then my current subarray sum is already stored in this csum variable. So if I add this element ARR of I with my current subarray sum, then I'll get the subarray sum till this element, right? Including this element. So my current subarray sum could either be this element or current subarray sum plus ARR of I. So whichever out of these two is the maximum, it would be stored inside my current sum variable. Similarly, my maximum subarray sum would be maximum of either itself, either any previous maximum sum or my current sum, right? So that completes the whole approach. So now let's move on to the code. So firstly, I'll create a vector ARR of size n. Then I'll input all the n numbers, or I'll simply store all the n numbers inside this vector ARR. Then I'll create two variables, csum and msum, and I'll initialize them both by ARR of 0, which is the first element inside the vector. Then I'll start a loop from the second element of this vector till the last element of this vector, and I'll simply store the maximum of csum plus ARR of I and ARR of I inside this csum variable, and the maximum of msum and csum inside this msum variable. After this, I'll simply print this msum, which is the maximum sum. Remember that to use this max function, you have to include this header file called as algorithm, right? So if I run this code, then this is the exact same input. So I should get a 6 for it. So here we can see that our output is 6, right? So that is it for this video. Like if you understood the concept. In case of any doubts or feedback, do leave them in the comment section below. Subscribe to our channel and press the bell icon to get notified about our upcoming uploads. You can also join our Telegram group. The link is in the description, and I'll see you in the next one.